Alright, ladies and gentlemen, welcome back to this Athenian Stranger tutorial video where today we are going to work through this isosceles and equilateral triangles worksheet. So remember that the isosceles triangle theorem, ITT, says that if you have a triangle where two of the sides are of the same length, okay, and that will be indicated with these little marks, two of the sides are the same length, then the angles opposite those sides are congruent. That's the basic idea. So we're going to apply that theorem in number 1. We're given a triangle STU, and we're provided the measure of angle S as 54 degrees, and we're told that legs of this triangle ST and TU are congruent, and that's indicated by these little dash marks on the lines on the sides. So in order to find the measures of angles T and U, the first thing we have to do is understand that if angle S is opposite of this leg and this leg is congruent to this leg, which it is, then the isosceles triangle theorem says that the measure of angle U has to be congruent to the measure of angle S. So the measure of angle U is 54 degrees by the isosceles triangle theorem, ITT. Measure of angle U is 54 degrees. Well, now that we know that, we can apply the triangle angle sum theorem, which states that the interior angles of a triangle have to add to 180. We can apply that theorem to find the measure of angle T. So that's what I was going to do here with this side work. What we do is add 54 and 54, and then subtract that sum from 180. So 4 plus 4 is 8, and 5 plus 5 is 10. So the sum of those two interior angles is 108. And by the triangle angle sum theorem, I know that if I subtract 108 from 180, I'll find the other angle. So we'll borrow here. 8 from 10 is 2. 0 from 7 is 7. So the missing angle, the measure of angle T by the triangle angle sum theorem, is 72 degrees. Okay, that's number 1. Now let's move on to number 2. In number 2, we are provided that two of the legs of the triangle are equivalent, but we're provided the angle measure for an angle that is not congruent to any other angle in the triangle. If you turn the picture like this, it's easier to see that the angle opposite of this side is M, and the angle opposite of this side is N. So by the isosceles triangle theorem, the measures of angles M and N are congruent, but we don't know either measure. So how would we find it? Well, we can use a little bit of algebra and we'll kind of combine the theorems, the triangle angle sum theorem and the isosceles triangle theorem, to find the missing angle. So we are going to understand that M and N are congruent. And I'm going to say that the measure of both of those angles we're going to call X. Okay, so the measure of angle M is X and the measure of angle N is X. What that means is that I can kind of construct a little algebraic sentence that says 2 times the measure of angles M and N, which is going to be called X, plus the measure of angle L, which is 28 degrees, by the triangle angle sum theorem, have to add up to 180 degrees. So we just solved this little algebra problem by subtracting 28 from both sides and then dividing by 2. So we'll borrow here. 8 from 10 is 2. 2 from 7 is 5, and we bring down the 1. And now we divide that by 2. I'm going to do this upside down division. It's the same division, just upside down. 2 goes into 15 7 times with 1 remainder. 2 goes into 12 6 times. So x equals 76 degrees, and x is the measure of angle M, and x is the measure of angle N. So we'll check that here in a moment. If this is true, then we should be able to add 76, 76, and 28, and they should add up to 180. So 6 plus 6 is 12, plus 8 is 20. So we'll carry the 2. 7 plus 7 is 14, plus 2 is 16, plus 2 is 18. And so they all add up to 180. All right, so we can say here that we used both the triangle angle sum theorem and the isosceles triangle theorem. We had to use both to get those measures. Okay, number 3. Here we are given that 2 angles of a triangle are congruent. And by the converse of the isosceles triangle theorem, CITT, the converse, it's kind of like the other way of looking at that theorem is if you have 2 congruent angles, right, then you have 2 congruent sides. So if angles E and G are 23 degrees, then that means the sides opposite those angles are congruent. So if leg GF is 18 inches, then leg EF is also 18 inches. And this is by the converse of the isosceles triangle theorem. Okay? So this is 18 inches. Now for the measure of angle F, we'll just use TASTE, the triangle angle sum theorem, because we have 2 of the 3 interior angles of a triangle. If we add 23 and 23 and subtract that sum from 180, we'll find the missing angle. So here's the side work for number 3. We have 23 and 23, and those add up to 46, and we subtract 46 from 180. And 6 from, we have to borrow. 6 from 10 is 4. 4 from 7 is 3, and we bring down the 1. Okay, so by the triangle angle sum theorem, we find the measure of angle F to be, and here I just didn't look at it, 134 degrees. Okay, so now on to number 4. Let's take a look at this. In number 4, we have all sides congruent. Okay, so if all of the sides of a triangle are congruent, all of the angles of the triangle are also congruent. And there is a theorem about that. It's something about the equilateral triangles. If all sides are equal, then the angles are equal. Let's see. Okay, so we can prove that all the angles are equal by side, side, side. All right, so all 3 sides are congruent, so all 3 angles are congruent. So we have to think of what angles, if all the angles are congruent, what are the angles? Well, all we have to do here is divide 180, which is the total number of interior angles measures, has to add up to 180. So we just take 180 and we divide by 3. Okay, So 180 divided by 3 is 60. That means that all of the interior angles have to be 60 degrees because they all have to be equal. So this is the side, 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 and the triangle angle sum theorem. Gives us that P, Q, and R are all 60 degrees. Okay, so number 5. Here's where it gets a little bit more frustrating because we introduce the algebra. Here we're asked to find the value of each variable. There's only one variable, it's x. And by the Isosceles triangle theorem, we know that these two angles being the converse of the Isosceles triangle theorem, rather, CITT, says that if these two angles are the same, the sides opposite those angles have to be congruent. So we could set up an algebra problem that just sets 4x plus 23 equal to 10x minus 1. And the reason I'm doing all this on scratch work is because last time I kept running out of space on the page and it looked all cramped. So by the converse of the Isosceles triangle theorem, we just find x by setting these two side lengths equal to one another and solving for x. So we'll solve for x on the left side. I'll subtract 10x from both sides. This gives me negative 6x plus 23 equals negative 1. And now I'll subtract 23 from both sides. Oops. So negative 6x equals negative 24. And if we divide both sides by the x coefficient, which is negative 6, we find that x is equal to negative 24 divided by negative 6. Well, a negative divided by a negative is a positive, and 24 divided by 6 is 4. So x equals 4. So we write x equals 4 by the converse of the Isosceles triangle theorem. Number 6, let's see what horrors lie within. So in number 6, we have to find the value of x, and we're given that these two side lengths are congruent. So by the Isosceles triangle theorem, we know that the angles opposite those sides are congruent. So this angle right here is congruent to this angle right here. And that means that 9x, I'm going to do it in side work here. Here's the side work for number 6. That 9x minus 25 is equal to 9x minus 25. Oh, they have to be equal to one another because that's what the Isosceles triangle theorem says. So let's see how this works out. I think I'm going to get 0, aren't I? Yeah, this was a stupid move. All right, so this is not the way to solve this problem. I'm sorry. Forget that. I mean, that's a true statement, but that doesn't help us solve the problem. I just wrote down something that was going to tell me that 0 equals 0. No need to prove that right now. Although in graduate mathematics, you could spend an entire semester trying to prove that. Okay, so let's look at the triangle again. We know that the two interior angles of the triangle that are opposite of those sides have to be equal. And we're given the other angle. we know that by the triangle angle sum theorem, all those have to add up to 180. So I'm going to set up an algebra problem like I did before, where I say that 2 times whatever that other angle is, okay, which is right here, 9x minus 25. So 2 times 9x minus 25, this is kind of what I was getting at before, plus 104 have to add up to 180. So the first step here, we really do it either way. We'll subtract 104 from both sides. And we'll do 180 minus 104, and we'll have to borrow. 4 from 10 is 6, 0 from 7 is 7, and 1 minus 1 is 0. So now I have 2, open parentheses, 9x minus 25, close parentheses, equals 76. So what I can do, there's two things you could do. You could distribute and multiply that 2, all right? Or you could simply divide both sides of the equation by 2 and just get rid of it entirely. And that's what I'm going to do. So both ways are effectively the same thing, and you would get the same answer if you did this the other way. What's 76 divided by 2? Let's see, 2 goes into 7 3 times with 1 as a remainder, and 38. Okay. So now I have 9x minus 25 equals 38. And let's add 25 to both sides, and then divide by 9. Now I have 9x equals 38 plus 25. So 8 plus 5 is 13, carry the 1. 3 plus 2 is 5, plus 1 is 6. So now I have 9x equals 63. And we'll divide both sides by 9 to get x by itself. And x equals 63 divided by 9, which is 7. So x is 7. And we used a combination of the Isosceles triangle theorem and the triangle angle sum theorem. Number 7 might be more beneficial to turn and look at it like this. All right, so you've got a triangle here with two sides that are congruent, which means that the angles opposite those sides are congruent by the Isosceles triangle theorem. And we are given measures for those angles in algebraic expressions. So we just have to set them equal to one another in order to find out what x is. Okay, so we'll do that in side work. Let's see here. Side work for, let me just take a quick second here and separate out all my side work. Should be doing a better job of doing this side work, making it look a little bit more professional. But you know, I was always like a messy person when it came to the side work, just kind of write it anywhere, and that's really not good. Okay, let me section this off. Okay, so now we can kind of work. Here in number 7, we'll do down here. So we have here these two algebraic expressions that are congruent to one another by the Isosceles triangle theorem. 8x minus 55 equals 5x minus 7. And the way we can say that is by the Isosceles triangle theorem. That's how we can say that. So we add 55 to both sides. and we get 8x equals 5x. And now we have to basically say 55 minus 7, which is 48. And now I can subtract 5x from both sides to get these terms combined. And I've got 3x equals 48. Okay, well 48 is divisible by 3 because 4 plus 8 is 12. So we'll divide both sides by 3. The way I think about it is if 48 divided by 6 is 8, then 48 divided by 3 must be double 8, which is 16. So x equals 16. All right, that's by the Isosceles triangle theorem. X equals 16. Okay, there. Wrote it there. X equals 16 by Isosceles triangle theorem. Okay, so number 8, we've got an equilateral triangle. Okay, so because it's equilateral, it's also equiangular. That means that all these angles have to add up to 180. And what I'm going to do is I'm going to use this algebraic expression and say 3 times all this, and I'll distribute the 3, equals 180. And I'll just solve for x. So that's what we'll do in side work here. Okay. Got to look up that, I guess that's side, side, side. So here we're going to be using side, side, side. Okay, so I have here 3 times 4x plus 8. And that's going to equal 180. So I'll distribute multiply. 3 times 4x is 12x, and 3 times 8 is 24. Okay, those have to equal 180. And now we'll subtract 24 from both sides, which I learned in Spanish is a dos lados. Okay, let's see. Now 12x equals 180 minus 24. Okay, we'll borrow here. 4 from 10 is 6, 2 from 7 is 5. So 12x equals 56. And that's not going to divide evenly, is it? What do we do wrong? Maybe nothing. Oh, 12x equals 156. Forgot to bring down the 1. That makes more sense. Okay, so now I'll divide both sides by 12. So x equals 156 divided by 12, which if you think about it, we all know our multiplication tables up to 12. 12 times 12 is 144. So just go up by 12. 144 plus 10 is 154, plus 2 is 156. So that means that x is equal to 156 divided by 12, which has to be 13. Okay, so 13 times 12 is indeed 156. So x equals 13. And we can say that we did side, side, side. And again, there is a theorem. We should take a second and look for it, Morelli. There is a theorem. Corresponding parts of congruent triangles are congruent. Okay, is that what I want to use here? Let's see. Oh. Well, anyway, there's some theorem, there's some word for it, but basically we have congruent sides, so we have congruent angles. There's something backing that up. Okay, so here we are in number 9. And we are asked to find x. It would help to notice here that we have two angles that are identical. Okay. So the sides opposite those angles also have to be identical. But notice this, the angles are 60 degrees. So 60 plus 60 is 120. And by the triangle angle sum theorem, 180 minus 120 gives us this angle here, which also has to be 60 degrees. So in fact, we're working here with an equiangular triangle, and because all the angles are congruent, the sides are congruent. So this side is equal to all the other sides. So we can just set 7x plus 19 equal to 11x minus 89 because the whole triangle is congruent. And the thing that I was looking at before is called CPCTC. CPCTC. Corresponding parts of congruent triangles are congruent. But that's more for if you have two different triangles. Yeah. Whatever. So they're equiangular and equilateral. What we'll have to do here is set 7x plus 19 equal to 11x minus 89 and solve for x. Here's number 9. And those two algebraic expressions were 7x plus 19 equals 11x minus 89. Gather like terms. We'll subtract 11x from both sides. And 7x minus 11x is negative 4x plus 19 equals negative 89. And now we'll subtract 19 from both sides. And I'll have negative 4x equals negative 108. Okay, and now we'll just divide both sides by the x coefficient negative 4 to get x by itself, and x will be equal to negative 108 divided by negative 4. Okay, so 4 goes into 10 2 times with 2 as a remainder. 4 goes into 28 7 times with no remainder. So x equals 27 because it's two negatives divided. All right, let's go back to number 9. X equals 27. And first we applied the Isosceles triangle theorem, and then we applied taste, and then we applied side, side, side. That's the best I can do as far as proving how we did that. First we noticed that 60 and 60 mean that these two are the same, and then we checked to see that this other angle was 60, and then we said, well, all the sides are the same, so we set these two equal to one another and solve for x. That was that chain of reasoning, however flawed. Okay, and now on to number 10. Let's see, number 10 is an isosceles triangle. Okay, these two sides are congruent, so the angles opposite those sides are congruent. So that means that by the isosceles triangle theorem, this angle is also 29 degrees. So what we can do is we can figure out what the missing angle is by adding them together and subtracting from 180. Okay? Watch what I mean. I'm going to need another page now. This is going to be number 10. First, I add these angles, and there could be other ways to solve this, but by the triangle angle sum theorem, I'll say that 29 and 29, okay, those added together and subtracted from 180 will give me that missing angle. Eight from 10 is 2. 5 from 7 is also 2. Bring down the 1. Okay, so by the triangle angle sum theorem, I know that this angle right here is 122 degrees. Okay, so we don't want that though, we want to find x. So let's just set 122 equal to 11x minus 65. Okay, so 122 is equal to 11x minus 65. So I'll write 11x minus 65 equals 122. We'll add 65 to both sides. And now I have 11x equals the sum of these two. Okay, 5 plus 2 is 7. 6 plus 2 is 8. And 1 plus 0 is 1. So 11x equals 187. That's the police code for homicide, 187. And now I'll divide both sides by 11. And look, so we've got the Stranger Things there, 11. X equals 187 divided by 11. And boy, I sure do hope that that divides evenly. What would it be? Okay, I'm tempted to see, I reached for the calculator, but I didn't turn it on, okay? Go away. I don't know it off the top of my head, but we'll just do long division and figure it out. So 187, if you've already got it, then you can just look at me be dumb here. Divided by 11. 11 goes into 18 one time. Okay, 1 times 11 is 11. 77. Okay, so it's 11 goes into 77 7 times. So x equals 17. I fought that lazy tendency, and I should have been better about memorizing my times tables. What is this, number 10? Okay, so number 10 equals 17. X equals 17. And we use the Isosceles triangle theorem, or, yeah, we use the Isosceles triangle theorem. And then we use taste. That's how we did that. Number 11 looks like a nightmare. Really does, doesn't it? It tells us that ABC, okay, let me show you triangle ABC. That's the big triangle here, the big tent around the outside. So let's highlight that. This big triangle here is an isosceles triangle. That's what it's telling me. Okay. And then it's also telling me that triangle DBE, that's this triangle inside, is an equilateral triangle. Okay, so this triangle inside, let me use this green highlighter here. This triangle is an equilateral triangle. Let me just get this stuff marked in here. I know some of you want this to move faster, but then, first of all, I can't move any faster because I really don't know what to do just yet. I haven't seen it all. And second, you got to understand, if you're one of those people that can fly through these problems, then maybe you don't need to be watching this video in the first place, right? But I was going too fast in the previous video, and I had a great student, very hardworking student, come up and tell me that even with the video, they didn't have a clue what I was doing because I was just going super fast and trying to get it done. So I'm going to go slow, and you're free to not watch the video, or you're free to speed up the video or skip ahead. But let's figure this out. So ABC is isosceles, and we're supposed to find each missing measure. Okay, so here's what we know. We know that ABC is isosceles, and that means that this angle here is equivalent or congruent to this angle over here. Okay? These two sides have to be congruent. That's what the isosceles triangle part of it means. And the equilateral part of it says that these inner sides here also have to be congruent to one another. So these angles, 5, 4, and 6, all have to be congruent to one another. Okay? So we should be able to solve the triangle from here. The first thing I want to get out of the way is to solve for x. So I know that by the isosceles triangle theorem, 4x plus 3 has to be equal to 9x minus 47. So let's go ahead and get those angles. Okay, this is number 11 here. So I'm going to write out what I'm solving for. So this first part here, I'm going to solve for angles 1 and 9. Okay, that's what I'm doing right now. And by the isosceles triangle theorem, I've got 4x plus 3 equal to 9x minus 47. So let me gather my x's together by subtracting 9 from both sides, or 9x from both sides. 4x minus 9x is negative 5x plus 3 equals negative 47. And now we'll subtract 3 from both sides. And I have negative 5x equal to negative 47 minus 3, which is negative 50. Okay, I feel like we're on the right track here since this is going to divide evenly. We'll divide both sides by negative 5 to get x by itself, and x is equal to 10. So now that we know x is equal to 10, we can plug it back in. We just have to plug it back into one of our original expressions since we know the angles are equivalent. So 4 times 10 plus 3 equals 40 plus 3, which is 43. So that means that the measures of angles 1 and 9 by the Isosceles triangle theorem, both have to be 43 degrees. Okay. So we'll go over here and write that in. Measures of angle 1 and 9 are both 43 degrees. Notice here that we have an equilateral and equiangular triangle here in the middle. Okay, so that means that all these three angles, 5, 6, and 4, or 4, 5, and 6, they all have to be congruent. So there's no math involved. We know that an equilateral equiangular triangle has to have 60-degree angles, because that's the only way that they can all three be the same and all add up to 180 by the triangle angle sum theorem. So I've got 4, 5, and 6 done because they're all three 60 degrees. Okay? Well, now that I know that those are all 360 degrees, I can find angles 3 and angles 8. Okay? They have to be identical, all right? Because they both form linear pairs with angles 4 and angle 6. So they have to be the same. 3 and 8 have to be the same. So all I have to do is, by the supplementary angles theorem, because these adjacent angles are supplementary to one another, they have to add up to 180. I know that these angles are both 60, right? So that means that 180 minus 60, 120, have to be the measures of angles 3 and 8. Okay? So 3 and 8 are both 120. Now how about 2 and 7? Well, 2 and 7 have to be equivalent to one another, okay, because they're split by this equilateral triangle here, and the whole triangle around the outside is an isosceles. So how would we figure it out? Well, we know that they're equivalent. So there's two ways to do it. We know that this angle is 60 degrees, okay? We know these two angles, angles 1 and 9, are both 43. Okay, so we have multiple ways to do this. You could solve this in multiple ways. Because we know that angle 3 is 120 and angle 1 is 43, we could add these two together and we could subtract from 180 to get angle 2, and that would be equivalent to angle 7 because the other angles over here are also congruent to these angles. Or we could say 43 plus 43 and subtract that from 180, and then subtract 60 from that, and then divide the result by 2 to get angles 2 and 7. Let me show both methods so you understand what I'm talking about. So now this is angles 2 and angle 7. All right, so here's the thought process here. That big triangle that I had in red, its two angles that were identical were both 43 degrees, and we proved that by isosceles triangle. And so together that's 86, and we subtract 86 from 180. Okay, and we get 94, or we should get 94. We get 84, I can't remember. All right, so 6 from 10 is 4, and 8 from 17 is 9. Okay, so good. All right, so now we've got here that 94 is the combined angle 2, 5, and 7. All right, that's that whole angle up there is 94. We have a piece of it. We've got that 60-degree part. So we can subtract out 60. That's that middle part. 4 minus 0 is 4. 9 minus 6 is 3. And what I can do is understand that the 2 and 7 have to be congruent, so 34 divided by 2 would give me the measures of angles 2 and 7. So we'll divide 34 by 2. 2 goes into 3 once, with 1 as a remainder. 2 goes into 14 7 times. So the measures of angles 2 and 7 are 17 degrees. But I want to prove that to you using the triangle angle sum theorem. So these little triangles over here on either side of the middle triangle, the two interior angles that we already knew were 43 and 120. So if I add those together, I get 163. And if I subtract 163 from 180, I should get 17. Three from 10 is 7. 6 from 7 is 1. All right, so I get 17 by the triangle angle sum theorem, just to prove to you that that was right. So angles 2 and 7 are both 17. And now we've solved all the measures of the triangle there. What's next? The other side of the page? Where's that at? Here we go. Oh, great. So now we're going to have to approximate some kind of drawing for these. And I just like to, let's see, AC is congruent to CB. All right, so saying that's an isosceles triangle. We'll draw an isosceles looking triangle. Okay. And AC is congruent to CB. So how do I want to label this triangle? We'll label this C, this A, and this B. And that way AC is congruent to CB. Makes visual sense. Well, that means the angles opposite those sides are congruent. So these two angles are congruent. The measure of angle A is 3x plus 18. Right? So this angle is 3x plus 18. The measure of angle B is 7x minus 58. Well, we know that they're the same by the isosceles triangle theorem. The measure of angle C is 2x minus 8. Find x and the measure of each angle. Well, there's two ways we could go about it, right? We could add up all of these and set that equal to 180, because we know that all of the interior angles of a triangle have to add up to 180 by taste, the triangle angle sum theorem. Or by the isosceles triangle theorem, we could set 3x plus 18 equals to 7x minus 58, solve for x, and plug x back in and find the measure of each angle. Either method will work. Since this is about isosceles triangles, I will use that isosceles triangle theorem. Okay, so I have here 3x plus 18 equals 7x minus 58. The other thing I was saying that you could have done is you could say, well, 3x plus 18 plus 7x minus 58 plus 2x minus 8 all have to add up to 180. Okay, so you could solve it in either of these ways, and you should get the same x value. All right, I'll do both just so you can see which one you wanted to use. So first let me subtract 7x from both sides over here. And this is a good way to check your work as well. So this is negative 4x plus 18 equals negative 58. Okay, and now I'll subtract 18 from both sides. And we have negative 4x equals negative 76. And we will divide both sides by negative 4. And say x equals negative 76 divided by negative 4. Well, negative by a negative is a positive. 4 goes into 7 once with 3 as a remainder, and 4 goes into 36 9 times. So x equals 19. Let's check it. Over here, we should be able to find the same x value. Okay, so this was by the Isosceles triangle theorem, and this is by the triangle angle sum theorem. Let's see if we get the same answer. So 3x plus 7x plus 2x is 12x. Just combining like terms there. 18 minus 58 is negative 40. Minus 8 is negative 32. Negative 40. No, negative 40 minus 8 would be negative 48. I hope I did all that right. And that's equal to 180. And now we add 48 to both sides. And we have 12x equals 0 plus 8 is 8. 8 plus 4 is 2. Carry the 1. 228. Okay, so let's divide both sides by 12. And let's hope that 228 divided by 12 equals 19. If it does, then we're good. If it doesn't, then we're not good. So 12 goes into 22 once. Okay. $108. How many times will 12 go into 108? Well, 8 times 12 is 96. So 96 plus 12, 106, 108. So it is 19. Whew. All right. I feel good about that now. That x equaled 19 in both different ways of solving it. So you can decide which one was harder. All right, so now we know what x equals. X equals 19. Okay, not 19 degrees, just 19. And now we just have to plug that in and find out what a, b, and c equals. I bet we can almost do it in our heads. 2 times 19 is 38 minus 8 is 30. So the measure of angle A is 30. Oh, and now we know that these two angles have to be the same. So think about it this way. 180 minus 30 is 150. Okay? And these two angles have to be the same. So they have to add up to be 150. So they should both be 150 divided by 2, which is 75. Okay, so these angles should both, not 77, dodo bird, 75. These angles should both be 75 degrees, but we can check that. Let's try 3 times 19 plus 18, all right, just to check, because we should get 75. All right, so what is 3 times 19? Okay, that's 57 plus 18, and this should be 75. And it is. Okay, so we are correct. Those are all the measures there. That's number 12. What about number 13? New piece of scratch paper is needed. Okay, number 13. In triangle QRS, if QR is congruent to RS, so again we have another isosceles triangle. It's just important that you label it correctly, right? So we want these sides to be equivalent to one another. So this has to be Q, and this has to be R, and this has to be S. So QR is equivalent to RS, or congruent to RS. That means that measure of angle Q and measure of angle S have to be congruent by the isosceles triangle theorem. And we're given that Q is 8x minus 17. That's this angle here. And we're given that S here is 5x plus 1. And we're given that R is 19x plus 4. So the trick in these problems is setting up the correct isosceles relationship and labeling it correctly. All right? So like the way to think about it is, you see how QR is equivalent to RS? That's why I'm putting the R at the top of the triangle. Up here I did the same thing. AC was congruent to CB, so I put the C at the top of the triangle. That makes sure that way I make sure that I'm going to label the triangle correctly. Okay, so it's the same type of thing. We're going to first solve for x, and I hope at this point I've proven that we can just do 8x minus 17 equals 5x plus 1. But you could also do 8x minus 17 plus 19x plus 4 plus 5x plus 1 equals 180 and solve for x that way. But it just seems easier to do it the other way. So over here in side work for number 13, we'll do, so this is going to solve for x, right? This is what I'm doing right now. I'm solving for x. By the isosceles triangle theorem, I know that 8x minus 17 equals 5x plus 1. Okay, so now I'll subtract 5x from both sides. And here I've got 3x minus 17 equals 1. And now I need to add 17 to both sides. And I've got 3x equals 18. And divide both sides by 3. So x equals 18 divided by 3, which is 6. X equals 6 by the isosceles triangle theorem. And now we can just plug x in to all of our different things. So the measure of angle Q is equal to 8 times 6 minus 17. Okay. The measure of angle R is equal to 19 times 6 minus 17. And the measure of angle S is equal to 5 times 6 plus 1. And you don't have to solve all these. All right, you really just need to solve this one because we know the measure of angle S is equivalent to the measure of angle Q. All right, so these two things have to be equivalent. So first let's find, see, Q and S have to be the same. So first let's find out, we have 5 times 6 is 30 plus 1, and this is 31. Okay, by the isosceles triangle theorem, this is 31 as well. And we can add them together and subtract from 180 to get the measure of angle R using taste. So we'll use taste here. Here we used isosceles triangle theorem. So 31 plus 31 is 62. And so we just need to do 180 minus 62 to get the measure of angle R. 2 from 10 is 8. 6 from 7 is 1. And we bring down the 1. So we have here 118 degrees. Right? So x is 6, and these are the measures of the angles. X is 6. The measure of angle Q is 31 degrees. The measure of angle R is 118 degrees. The measure of angle S is 31 degrees. Okay, so that's number 13. Number 14. Let's do it on the paper first. In triangle KLM, if the measure of angle K is congruent to the measure of angle L, and KL equals 9x minus 40, and LM equals 7x minus 37, and KM equals 3x plus 23, find x, the measure of each side. So we want angles K and L to be equivalent to one another. So here we're going to be using the converse of the isosceles triangle theorem. Okay, so I drew this little TP shape, and this has to be K, and this has to be L, because I want these two to be congruent. So it says they're congruent. So these two sides have to be congruent. All right, so this must be M. So I want to see that triangle labeled that way. Otherwise, you're not showcasing to me that you understand what's going on. Now it says side length. This is, we're finding side lengths, the measures of each side. So here's the important thing. KM and LM we found using the converse of the isosceles triangle theorem, which says that if K and L are the same, the sides opposite those angles are the same. This is the converse of the isosceles triangle theorem. Okay, now KL was given. Okay, it was given. And we have to find x. All right, so let's go to our side work here. We know that KL, this distance right here, is 9x minus 40. I guess I should write it in, huh? Well, no. Okay, so we know that LM is 7x minus 37. That's this distance is 7x minus 37. And KM is 3x plus 23. All right, well, we know that these two are equivalent to one another. The KL is 9x minus 40 down here. This is 9x minus 40 down here. So let's go to side work and find out what x is. And we're going to use the converse of the isosceles triangle theorem to prove that 3x plus 23 equals 7x minus 37. So this is, this is number 14. We're going to find x. All right, so by the converse of the isosceles triangle theorem, we know that 3x plus 23 is equal to 7x minus 37. Okay, so let's find x now. Subtract 7x from both sides. Okay, so I have here negative 4x plus 23 equals negative 37. And now I'll subtract 23 from both sides. And I have negative 4x equals negative 3 plus 2 is 5 plus 1 is 6, negative 60. Divide both sides by negative 4. Okay. So x is equal to, and here we divide 60 by 4. Well, let's see. 4 goes into 6 one time with 2 as a remainder. And 4 goes into 25 times. So x is 15. Well, now that we know that x is 15, it's just a matter of plugging in. So here we have side km equal to 3 times 15 plus 23. We have here side LM equal to Km by the converse of the isosceles triangle theorem. And we have here KL equal to 9 times 15 minus 40. And that was given to us, okay? So we just have to figure it out. All right, so a little side work here for Km. 3 times 15 is 45. Okay, so we just have to do 45 plus 23. And that was 5 plus 3 is 8, and 4 plus 2 is 6. So Km is 68, not degrees, it's just side length. And Lm is equal to Km by the converse of the isosceles triangle theorem. So this is 68. And now we have to do 9 times 15. So I guess that would be, okay, so this is 135 minus 40. I guess that would be 95. Okay, so KL is 95. There you go, Km. So X is 15. KL is 95. LM is 68. And Km is 68. All right, we're down to the final problem, number 15. In triangle XYZ, if the measure of angle X is congruent to the measure of angle Z, and KY or XY is equal to 13x minus 2, and yz is equal to 8x minus 6, and xz, for some reason that x looks like a k, that xz is equal to x plus 4. Find x and the measure of each side. All right. Alrighty, so let's draw this triangle here. Now, which angles need to be the same? X and Z. Okay. So draw your triangle so it looks isosceles. And we're going to make angle X be here and angle Z be here. And so that means that this is Y. Okay, so now what? We know by the converse of the isosceles triangle theorem that these two sides have to be the same. It says xy is 13x minus 21. Xy is 13x minus 21. Yz is 8x minus 6. And xz is x plus 4. All right, so these are our little algebra problems here. The process for finding it is the same as above. We know that 13x minus 21 is equal to 8x minus 6 by the converse of the isosceles triangle theorem. So we can find x that way. Okay. Alrighty. So what I say, we're going to find x by the converse of the isosceles triangle theorem. So we have 13x minus 21 equal to 8x minus 6. And we'll just solve by subtracting. We'll start it off by subtracting 8x from both sides. 13x minus 8x is 5x minus 21 equals negative 6. And now we'll add 21 to both sides. And we have 5x equals 15. And now we'll divide both sides by 5. And we get x equals 3. All right, so now we have x equals 3, so it's just a matter of doing some legwork here on these other little problems. So xy, alrighty, is going to be equal to 13 times 3 minus 21. And we know that yz equals xy by the converse of the isosceles triangle theorem. And xz equals x plus 4. Okay, and x is 13, or x is 3 rather, so it's just 3 plus 4. Let's go ahead and get that one. I just said what I meant to write, 3 plus 4 equals 7. 3 plus 4 equals 7. Okay, so xz is 7. Let's find xy now. Well, 13 times 3 is 39. Okay, minus 21. So 39, 29, 19, 18. Should be 18, right? So let's check all of our work. 13 times 3 is 39. And 39 minus 21 is 18. So xy is 18. And since yz is equal to xy, then yz is also equal to 18. So let's go back here and transfer our work. X was 3. Xy is 18. YZ is 7. No, YZ is equal to XY, so YZ is 18. And XZ is 7. There you go. And so these are all the answers to the homework. Now, when I grade this, I'm going to be looking for very neat and orderly work just like this. All right, so we did 3 pages of side work. So if your paper just looks like this with the answers on it, I'm going to give it a nice big 0 because you need to show your work. Now, the intention of doing these videos is not just to give you all the answers so you do no work at all, or that you become a master copyist. The intention is that you use the videos here to help you with the work, but not to replace your own work. So you need to try it by yourself first, because on the test, I can't be there to give you the answers, all right? Well, good work today. This was a bit of a long video. It took 1 hour and 17 minutes. But, you know, like I say, I won't ask you to do anything that I wouldn't do myself. And so the only way I can prove that is by recording me just solving it all by hand. So at the very minimum, you don't think that your teacher is just assigning you work and then kicking back and doing nothing. Well, you have to do all the hard work. I did it too, and it hurt, you know, my back hurts from sitting here. So I hope this was helpful. If it was, give the video a like and leave a comment, because that helps YouTube's algorithm let other people know about this channel. And please subscribe to the channel. I'd really like to get those subscription counts up. And for my students especially, hit that notification bell so you're always alerted to when I release new videos on this channel. Thanks so much.